I'm going to discuss about how to simulate a heat transfer problem, or how to solve a heat transfer problem using ANSYS. So if you closely look at the problem now, you have a bracket. The dimensions of the brackets are 300 into 500. Okay, length is 500 mm and width is 300 mm. In the center, you have a hole of 100 mm diameter. So here, this side is maintained at temperature at 300 Kelvin, and the other side no. So this is maintained at 700 Kelvin. Heat flux is applied on the top surface. If you clearly observe, no, the thickness of the bracket is 20 mm. They already provide you with the value of K. So K is given as 500 watts per meter Kelvin. So heat flux value is 10 watts per square meters. Now I'm going to model this and perform heat transfer analysis. So if you closely look at the values given, no, so I want to maintain the dimensions like lengths in terms of meters, temperature in kelvins. Okay, so let me move to ANSYS APDL. So I want to create a new file. So I'm using this launcher. So let me create a folder and pick a job name. So this is actually the exercise number 11. So I will name it as heat transfer problem. Okay, if you run the software, just click run. Then it will create a folder and a job. So up to now we discussed about structural problems. No, so now I will set the preferences as thermal, since we are this problem is related to heat transfer analysis. So let me move to preferences. Instead of picking structural, no, I'm picking thermal. Click OK. So now first thing is you need to define the element. So since this is a 2D problem, so I want to convert this into a 2D problem. Here the thickness is very small when compared to the length and the width. So I assume the given problem as a 2D. So let me select a 2D element. So go to preprocessor. Let's pick the element type as, so under thermal, I'll select solid. Let's pick quadrilateral 4 node 55. I want to select this. Click OK. So since it has some thickness now, I will add the thickness as an option. Let's check whether I can use that or not. Go to options. See, it is it says it's plain now, but I can go for plain with thickness. If they didn't specify the thickness, then you can go for plain. Since they provide you with the thickness, I'm picking plain thickness. Click OK. So you need to add the thickness as a real constant. Let me close this window. So after selecting the element type, let's define the thickness as a real constant. So I'm picking this real constant option. Let's add thickness to that particular element. So I want to specify the dimensions, that lengths in terms of meters. So it should be 0.02 meters. Okay. So it's clearly specified now 20 mm now. So I want to convert that into in terms of meters. So after defining the real constant, close the window and move to material properties. Let's select a material model. So since you are dealing with thermal, you don't find properties that are related to structural, like isotropic or so on. So you need to specify the thermal properties. Let me pick thermal option. They specified thermal conductivity now. So I want to pick this thermal conductivity option. I'm picking isotropic. Let's define the K value. So K value, it is given now. K value is 50 watts per meter Kelvin. Let's add that value here. It is 50 watts per meter Kelvin. Click OK. So I'm done with thermal defining the material model. Next, move to let me close this window. If you don't close window, these options won't be active. So suppose if these if the window is hidden now, you can press this option, raise hidden option. So let's create the model. So I want to create a area. You can also specify the key points and create lines using those key points. And after that, you can define an area based on the lines. But straight away, you have a rectangle option. So I'll directly go to areas option. So here I'm picking rectangle. You can pick any option. Like I will go for by dimensions. If you closely observe now, see, I will consider this as the center as 0, 0. So specify the coordinates, XY coordinates of that. So this should be minus 250 mm. Sorry, minus 150 and minus 250. But I need to specify them in terms of meters. Okay. So x1 should be minus 0.15. Y1 should be minus 0.25. Okay. X2 coordinate should be 0.15. Y coordinate is 0.25. Okay. Yeah, I made a mistake now. Okay, you can build it like this, or you can rotate the figure. Okay. So if you are not satisfied with this, I guess got confused with the coordinates. Let me redraw it. Okay, if you want to delete it, go to delete option, areas only. I will pick this area and click OK. Okay, so use the same procedure. Go to create by dimensions. So this should be the x coordinate should be minus 25 and y coordinate is 0.15 now. Click OK. I need to make a hole. So let me create one more area. So I'm using circle option. Let's create a solid circle. So here I'll specify the coordinates as 0, 0. Even though if you don't mention 0, 0, it will consider as 0, 0. Okay. Radius should be 100 now. So it should be 0.5. Let me add 0.5 mm. Sorry, 5 meters. It is 50 now. So let's add 0.05. Click OK. So now you have a circle. Now you can make a hole by just subtracting this particular area from the rectangle. So you need to use Boolean operations. Once again, under modeling, you have operate option. Use Booleans. I'm using subtract. Okay. Subtract areas. Now you need to select the, see here, it's specifying some information. It is asking us to pick base area from which to subtract. So I need to select the rectangle. Let's select the rectangle. See, it is picking area number 1, which is actually the rectangle. So I'm satisfied with this. Click OK. Then click OK. So once again, it is asking us to, you have another message. It says pick areas to be subtracted. So I want to select this circle. See, once again, since they are one above the other now, by default it is picking the rectangle, but I don't want to pick this. Here, the name it is picking as 1, but I need to pick the area number 2. So I will go for next. So now if you see, clearly the area 2 got picked. So I'm satisfied with this. Even you can add the value. Like if you want to pick area 2 now, you can put it here. Just type 2 there. Then automatically it will pick area 2. So I'm satisfied with this. Then click OK. I'm closing the, I'm applying this option, subtract, click OK. Automatically it will create a hole. So we use Boolean operation to make this hole. So after creating the model, okay, let me add mesh. I'm using I want to use the mesh tool option. I'll go for smart size. Okay, so instead of creating a coarse mesh, I will put somewhere here near to fine mesh. Even you can actually define the size of the elements. Okay, so since you are dealing with the areas, you can set the value here by using this option. Okay, but I want to go for smart size option. Since you have a circle here, I'll go for free mesh instead of mapped mesh. Mapped mesh, it will take time, but you may get better results. Okay, so I'll go for free mesh. In the previous case, maybe I used mapped mesh, but in this case, I'm going for free mesh. So I need to mesh the model. So see here, since you are dealing with the areas now, you need to select areas here. By default, it's picking areas. So leave it like that. And you're opting for quadrilateral elements, not triangular elements. Okay, quadrilateral elements are more flexible, so they give better results. So I'm opting for quadrilateral elements. So let me mesh the model. So just press mesh. Then it will ask us to select the area. So I'm selecting this area. Click OK. Automatically, it will create a mesh. So if you are not satisfied with this, you can go for clear mesh areas, select that particular area, click OK. So don't get confused. You don't have the display, but still area will be there. So to view the area, go to plot and pick areas option. Okay. Now let me remesh this. So I'm using the same mesh tool. I didn't close it now, so it's still available. So if some window is not visible to you, better to click this raise hidden option. So then whatever window that is open will be displayed. So now I will move a little bit closer to fine mesh. Once again, click mesh option. I'm selecting this particular area. Click OK. So this looks better. Okay. You can also check the mesh attributes. In this case, since you only selected a particular element, so by default it will pick that. Otherwise, you need to set the mesh attributes. And also, the material is same. Okay. So I want to check whether it is picking all the materials. Sorry. I'll check this information related to the attributes. Let's pick this option. Let's check. Okay. So here by default, you only have one element. No, plane 55 is got picked. Material number is 1. Real constant number is 1. So everything looks good. Click OK. So after creating the mesh, so let me save the database. Click Save Database option. Okay. So now I want to apply the boundary conditions. See, this side now is subjected to 300, I think. Okay, 300 Kelvin, and the other side is kept at 700 Kelvin. So let me add the boundary conditions. So move to loads. Okay. So under loads, you can define the type of analysis. I will pick steady state. Click OK. Now let's define the loads. I want to apply the loads on these two faces. I'll pick thermal loads. So under thermal loads, let me pick temperature. So since you are applying on this side now, which is actually represented by a single line, so I'll pick lines. Let's select this particular line. Click OK. So I will pick temperature now. So I'll select temperature, and it should be at 300 Kelvin. So here I'm not converting the temperature in terms of centigrade. I want to keep the temperature in terms of Kelvin. So I'll put it like this. 300. I don't want to say OK. If you say OK, once again you need to open, or let me click OK. See here, you applied a boundary condition. Once again, let me select line option. I'm selecting this line. Click OK. So the temperature should be 700 now at that interface. So it should be specified as 700. Click OK. So now I need to apply heat flux now. The heat flux should be applied on the top surface. So that means I need to pick this particular area. Okay. How much is the value for the heat flux? It is 10 watts per square meters. So I will click heat flux option. I want to apply it on the areas, not on the lines, but on the areas. So I'm picking areas. Let's select this. Click OK. So specify the value. It should be 10 watts per square millimeters. Sorry, square meters. Okay. Then click OK. So I'm done with the. Let me close this mesh window. I'm done with defining the boundary conditions. Let me move to solution. Let's solve this problem. So go to solution option. I already defined the analysis type now. Let me move to solve option. I want to solve this current load step. Click OK. Okay. So everything looks good and you got a solution. Let's close this. Now let me check the results. Okay. So to check the results, I'll use this general post processing option. Initially, I want to view the temperature distribution along this bracket. So go to plot results. Let's use the counter plot. So since you are dealing with the temperatures now, I will opt for nodal solutions. Okay. I want to pick the degrees of freedom. And in under this, I'm picking the nodal temperatures. Click OK. See, this is the temperature distribution. So since this problem is symmetric, so the counter plot is also symmetric. Okay. I hope you understood this. If you have any doubts, you can ask me. Any doubts?